Hello viewers, welcome to my YouTube channel Mathematics Made Easy. So in today's video we have this beautiful problem. It says solve the below simultaneous linear equation using determinant method. Now in my previous video I talked about matrix and how to add two matrices, how to subtract two matrices, and how to multiply two matrices in my previous video. Okay, but what we're gonna do today is to solve a simultaneous equation using determinant method. Okay, so that's what we're gonna do. Now the first thing that we're gonna do now is to rewrite this whole equation in form of matrix. Okay, in matrix form. Now before that, let me quickly remind us this. Let's say we have this kind of equation. This is general form of a simultaneous equation, okay, which is a1 x plus b1 y equals c1. Then we have a2 x plus b2 y, which is equal to c2. So if you write this equation in form of matrix, so the coefficient of x will be in the first column, which is a1, a2, and the coefficient of y will be the second column, b1, b2. And the two variables we want to find is x and y. Then everything will be equal to, you have your c1 and then your c2. Okay, so what we're going to do now, for us to make use of the determinant method, now we have the general determinant, which is denoted by delta. Okay, so we use delta for the general determinants. Okay, now this matrix, that's what we're going to use to find the general determinant. Since this is the general matrix that consists of all the coefficient of x and y in the given equation. Then how do you find determinant of 2 by 2 matrix? This is what you're going to do. So it's like you're cross multiplying, that is a1 multiplied by b2, a1 multiplied by b2, then minus a2 multiplied by b1, a2 multiplied by b1. That is how you find the determinant of 2 by 2 matrix. Okay, so we have a1 b2 minus a2 b1. Now how do you find, the next thing is to find determinant for x and the determinant for y. What do I mean to find determinant for x and y? Now for us to find determinant of x and y, now for x we call it delta of x. Okay, now in the first column we have the coefficient of x, so we are not going to write the coefficient of x for us to find the determinant of x. So you replace it with c1 and c2. That is, you're going to have something like this: c1 c2, then b1 b2. Then if you follow the same idea to find the determinant, that will be c1 multiplied by b2, then minus c2 multiplied by b1. Okay, so that's how you find the determinant for x. Now to find determinant for y, you do the same thing. Okay, so if you said check the second column, we have b1 and b2. Those are the coefficients of y, so we are not going to write the coefficient of y. You replace by c1 c2. So you're going to have something like this: a1 a2, then c1 c2. Then you follow the same idea. Okay, that is a1 multiplied by c2. So you have determinant of y equals a1 multiplied by c2, then minus a2 multiplied by c1. And then after that, after finding the determinant of x and y, the next thing you're going to do to solve for x and y is this. And then very simple. And then after that, you are done with the equation. Then you have your full mark. So x will be equal to determinant of x over the general determinant. Y will be equal to determinant of y over the general determinant, over the general determinants. Okay, now let's do that and then let's solve this given problem. So if you write this problem in matrix form, we have 2 1, we have 1 2, you have x y, then which is equal to 4 2. That's good. Now this is the general matrix, so we find the general determinant multiplied by 2 gonna give us 4, minus 1 multiplied by 1 will give us 1, and 4 minus 1 will give us 3. Okay, now that is the general determinant. Now let's find the determinant for x. So find the determinant for x, you're gonna rewrite the matrix. So we have the matrix, so instead of writing 2 1, what we're going to write, we're going to write 4 2. So we have 4 2, then 1 2. Okay, then if you find the determinant multiplied by 2 gonna give us 8, then minus multiplied by 1 gonna give us 2, and 8 minus 2 gonna give us 6. Okay, so that is the determinant of x. So we have determinant of x is equal to 6. Then now you find determinant for y. So you remove 1 and 2, then this will remain constant. Then you put 4 and 2 for here. So you're going to have 2, 1, 4, 2. Then you do the same thing. 2 multiplied by 2 give us 4. Then minus 4 multiplied by 1 will give us 4. And that's going to give us 0. So we have determinant of y equals 0. Now guys, so after solving for determinant of x and determinant of y, so we can now solve for x and y successfully. So making use of this definition. So we have we have x equal data of x over the general data, and data of x is 6. So we have 6, then the general data, which is 3. And this is going to give us 2. And then the value of y, that's data of y, which is 0, then over the general data, which is 3. And then 0 divided by 3 is going to give us 0. Then you can do check-ins, so if your solution is actually correct or not. So how do you do check-ins? Just input the value of x and y that you got into any of the equation. So let's use equation 1 for an instance. X is 2, you're going to have 2 into bracket 2, then y is 0. Then 2 multiplied by 2 going to give us 4. And 4 plus 0 is 4. Then you can see 4 here, 4 here. So that shows that the solution is correct. You can also put it in equation 2. X is 2, that will be 2 plus 2 into bracket y is 0. So this is going to give us 2 plus 0, which is equal to 2. You can see 2, we can see 2. So that shows that the solution is actually correct. Okay guys, so if you like this kind of video, please don't forget to like, comment, and share. Thanks guys for watching. See you next time.